Captain's log, stardate 2023, 10:01.12. In this episode, we're continuing our journey to build a vendor-agnostic multiplayer VR baseline, and we're implementing detailed finger movement over netcode for GameObjects. With that, we are approaching the borders of what's commodity and need to get more and more creative. In the last 10 minutes of the video, we will encounter a typical problem occurring when implementing multiplayer applications, so I'm explicitly showing that process. However, we will implement a rather unorthodox solution which bends the rules of Unity but demonstrates the level of creativity we will need in our future. We will continue our mission, which is to build our own metaverse, and doing so, we boldly go where no man has gone before. Engineering? Let's roll up our sleeves and get into the weeds. Engage. So before we start with the build, we need to do a little bit of design. We need to consider how much load we're going to put on the network versus how much load we're going to put on the CPU of our virtual reality device. So each hand has many bones. And unfortunately, if you want to replicate all of those over the network, that would be a lot of network traffic. So there's two options that I identified that we could use. First of all, let's just replicate all of the positions and rotations of each of the hand bones over the network. And you can imagine that's a lot of bones, like 40 plus bones that you need to replicate. Or let's say we only track the fingertips of the XR origin and we map those to the fingertips of the avatar. And we'll use inverse kinematics to simulate the movements of the other finger bones. And this way we would only need to send fingertip IK targets over netcode. So the CPU of the VR system will be more heavily loaded. So that's a trade-off, but I've decided to go with this option. So these are the following steps that we will take in the build phase. So in the Unity editor, we will create fingertip inverse kinematics in the avatar prefab. So that's the first thing we will build. And we have 10 fingertips, so it's 10 times the same amount of work. And once those are done, very similar to episode 5, we will enable the inverse kinematic targets for netcode so that the finger movements will be replicated over the network. Now we need to also script a part of that. So once we've created the inverse kinematics targets, we need to script that. So we need to create links to the avatar in the XR origin fingertip objects, again, 10 times. We need to connect the avatar fingertips to the XR origin, again 10 times, and then control finger IK based on controller's hands. So quite a lot of work, tedious work as well. Let's have a look at that. So to animate the fingers, we're going to follow a very similar approach as the hands approach that we had in the previous video. And we'll look at the position of the fingertip in relationship to the palm of the hand. What we have to do then is that we have to map the vector, if you may, between the XR palm and the XR tip of the hand to the avatar palm and the XR tip of the finger. And it's a bit of a formulaic thing and it looks ugly, so don't read too much into it. But technically what we say is that the fingertip position of the XR rig minus the fingertip position of the palm of the hand of the XR rig divided by the length of that vector should be the same as the fingertip of the avatar minus the position of the palm of the avatar divided by the length of the vector. And hence we can find the fingertip position of the avatar by taking the ratio of the avatar length and the XR length, so scale, and you multiply that by XR rig vector between the palm and the fingertip. And then we add up the local position of the avatar hand to that. So Looks complicated, but we'll go through that together. So what is the Humanoid Network Player script going to look like? So we're going to add a MapHands function, and that'll be a one-off. So we'll create 10 pointers to the fingertips of the XR origin. We will add 10 pointers to the fingertips of the avatar. And then in the update function, we will call a link avatar fingers to XR origin function, and that calculates that formula that we just had on our previous slide. And then we map the XR to the avatar tip rotations as well. We will also need a helper function to turn off or turn on the finger IK. Again, if we switch to controller mode, then we don't want the finger IK to be active, because then your fingers will look like a truck run over them, and that's not a pretty sight. So we want to have them in a natural position. So we're now back in Unity at the same place where we left off at the end of part number 5. Let's start with opening up our prefab, humanoid avatar. Let's double click that. The first thing that we will do, we will create a new object, and we'll create empty, and we'll call it left index finger IK. And we'll create a new child of that, and we'll call that left index finger IK underscore target. And make sure you type this exactly the right way. So IK with capitals, underscore, and target with a small letter. And that's important because we'll use GameObject.finds in the script later on. If you make mistakes, you get ugly null pointer references. On the left finger IK object, we now add a component, chain IK constraint, and we'll complete that in a second. So the first thing we're going to do now is duplicate those 4 times. So we have 5 fingers. We will call this the left middle finger, and this is the left middle finger IK target. The ring finger, finger IK, and then this should be the left ring finger IK target. Then this is the thumb IK, left thumb IK target. And then last but not least, left pinky finger IK, and this will be the left pinky finger IK target. Good. So this is the left hand, and then we can copy the same for the right hand. So again, this is pretty boring stuff. So we'll speed this thing up. I'll duplicate all of this, and we call this right index finger IK. So those are now all created, and then so let's configure them, and we'll do them finger by finger. And again, that's pretty boring work. So we'll start with the left index finger. We go to the XR rig, we go to the spine 1, spine 2. We'll go to the left hand first. So let's find the left arm, left hand, and now we open up the left index. And you will see that there are 4 bones in the index finger. So let's select the left index finger IK. We move the left hand index 4 to the tip field of the chain IK constraint, and left hand index 1 to the root of the IK constraint. So that means the tip will actually control everything up to the root. And which transform is that? Well, we'll drag drop the left hand index finger IK target in the target field. So then you select the left index finger IK target. So with the control button pressed, we click the left hand index 4. We go to animation, rigging, and align position. And if you look, you should be seeing that the left index finger target is now pointing to the left index finger. Okay, great. So let's repeat this for all of the other fingers. Okay, so the left hand should now be done. Great, so now we have to do all of this again for the right finger. Sorry, folks. Very boring work, but this is now completed. Okay, awesome. So now we are back in our script in Humanoid Network Player. Let's go all the way to the top because we need to define a couple of variables. We will say finger. So we want to have a transform array and we call it xrig left hand fingers. And we want to have an x right hand fingers. We also want an array of avatar left hand fingers and avatar right fingers. And we also create a transform of the left palm bone and a right palm bone. And we need a game object called hand visualizer. We will need that to identify whether or not the XR is properly initialized. And then finally, we need to have two bools, a left hand controller and a right hand controller. And this is to identify whether or not the left hand or the right hand has a controller or a hand. So we know if we need to enable or disable the inverse kinematics for the fingers. Okay, so that is all completed. Now let's go to on network spawn. And then after the return here, left hand fingers is a new transform of 5. Right hand fingers is new transform 5. Avatar left hand fingers and the avatar right hand fingers. Probably will not be a surprise. So that will now initialize some memory space for the fingers. Great. After the MyXRCam, let's do this here. Hand visualizer, game object, find, left hand debug, draw joints. This is a trick to identify whether or not the hand visualizer is active. If not, then this will be 0 and we can just check that. So we will then say if not hand visualizer, debug.log, at least we know that that is the case. Else, the left hand controller is GameObject.find, transform.find the palm of the hand, transform. And then the same for the right hand. The right hand is, I will do a copy paste because that is much faster. Right hand debug draw joints. And then within that we want to find the palm bone. We can now undo the left hand and the right hand because we don't need those anymore. So now let's go to on animator IK. After this debug.log, if hand visualizer exists, now we want to do the initialization of the AV left and the right position. And now we want to do a call to a new function that we'll just create, and that's called MapHands. That we are going to now create at the end of our file. Void MapHands. So this is a lot of boring work. So I'll go to 1 or 2 lines and I'll copy paste it in, and then we'll go over it and you can have a look. So first of all, we look at the XR origin. Xrig left hand fingers 0 is game object find, left hand debug draw joints transform, find index tip transform. And let's copy paste this 4 times. And so this is not index tip, this is middle tip, thumb tip, and let's call this little tip. Again, these are defined by the XR origin. Then we'll do the same for the right. So let's copy paste this. Xrig right hand fingers. And the fingertips are exactly the same names. Okay, right. So now we go to the avatar left. So for the avatar, left hand fingers 0 is transform.find. And we want to find the XRIK rig. And we also want to find the left index finger IK. And within that, we want to find the left index finger IK small letter D target transform. And well, I guess you know the fire drill. We'll copy paste this 4 times again. All right, like the most boring code ever. And then the last thing we need to do is find the palm bones. So the left palm bone transform dot find car IK rig find left index finger IK get component chain IK constraint data.root.parent has included Unity engines animations rigging. Okay, and we'll do the same for the right palm bone, right index finger IK, and we'll try to find the parent there. What we then need to do is we need to add some function which we call void link avatar fingers to XR origin. This will have a couple of inputs. It'll have a transform avatar bone, it'll have a transform R bone, and it'll have transform for which hand it is, left or right hand, right? So we now say for int I is 0, I smaller than 5, so for each finger. If avatar hand is AV left, then we want to do avatar bone I position is left palm bone position plus, and now we take the scale factor, but for now we take scale factor as 1. We take the XR bone position minus the my RLH dot position. And we don't need these, easier to read. And then we copy this for the right side. We want to have the avatar position is the right palm bone plus the XR bone eye position minus the right hand position. And then last but not least, we will make sure that the avatar bone eye dot rotation is avatar hand dot rotation. Okay. So then, last but not least, we need to define another two functions where you use the controllers. You don't want the inverse kinematics of the fingers to be active. So we will create a helper function called avatar turn on off left hand IK. Input will be a float for int I is 0 for each of the fingers. Avatar left hand fingers I parent get component chain IK constraint weight value. Now I need to obviously put some args here. So what we do here is that for the left hand, for each of the fingers, based on the value, and we can send the value 0 or value 1. If you put a 0 in, the weight of the IK constraint will be 0, means that the inverse kinematics will not be active. And if you make it 1, then it will be active. So now we copy paste this function and we create one for the right as well. Turn off right hand IK, right hand fingers parent constraint. So how do we now call all these things? So let's go back to update. One of the things we want to check after the update is if we don't have a hand visualizer, then let's also return. That means that if we are running this thing as a host and we don't have an XR rig enabled, don't even bother to do an update. So in the previous animation side, we added code here to control the animation. If you have a controller, that means that what you want to do is you turn off the avatar left hand IK, and you do that with a 0. And what we then do is that we say left has controller is true. So if you've switched, if you're in the controller mode and left half controller is false, that means you just came from a hand movement, you now need to turn off the hand IK. We do the same for the hand, so let's move that after the rotation. But now we say if left has controller is true, then you turn the left hand IK on, and then you turn left has controller to false, so this will only be executed once. And obviously we also want to add the link avatar fingers to XR origin with the avatar left hand fingers and the XR rig left hand fingers, and we want to do this for the left hand. If your input mode is a hand, then you want to each cycle update your finger position of the left hand, and then we also want to make sure that we turn on the IK. Then we go to the right hand input mode, and what we do here is very much the same. So we copy the code from the left controller, not right has controller. Avatar turn on right hand IK. Right has controller is true. Great, for the right hand. So we add the link avatar fingers, and we now link the right hand fingers to the right hand rig, right hand. So if right has controller, right hand IK, the right has controller. So you only do this once. So that should now run. The only thing we now need to do is go back into Unity, right? Open our prefab, go to the humanoid avatar, double click that. And now we need to go to all of the fingers. Let's open all of the fingers. And very similar to the hands, let's select all of the IK targets and we add a client network transform. Because now we want to make sure that these are all replicated over the network. We don't need scale, and that is completed. We should be ready to go and test. So let's have a look. Okay, so let's run this thing first in USB mode. We start as a host. Let's go into third person view. This is all still the same. All works. And so now let's go into hands mode. And there we are. Yeah, we can move our hands. Awesome. So thumbs up, one hands up, one piece. You can 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay, so that works. And now let's see if this also works in network mode. So let's compile this thing and build it. So it has now compiled. Let's start the host and start host mode. I'll go to the scene and then I'll join on the client. There we go. I'll switch to hand mode. And let's see, yep, my hands are now replicating over the network. It's not as fast, obviously, because there's some delay, but thumbs up, 1, 2, 3. So you can move all your hands independently and all your fingers. Perfect. That is working. All right. So everything works great now, does it? Well, no. Because, yeah, my fingers are working fine, but if I pick up my controller, you see that my fingers are completely deformed. And so that's a bit of unexpected behavior. Let's figure out what the root cause of that is. So when we look at the update function, we see at the bottom, we turn off the avatar left hand IK and the avatar right hand IK. And those functions are called from the switch statement. If left doesn't have the controller, we turn off the left hand IK. Well, unfortunately, for remote clients, there's no way my local system can identify whether or not they are using their controllers or their hands. It was a good example to see the situations where you bump into when you are programming on the network. So what happens? I call it the wrinkled finger syndrome. The approach that we had chosen is that it's not the XR rig that's replicated, but it's a local avatar. So when my system is processing the avatars from the remote clients, it doesn't get any signals from whether or not these avatars are using their hands or whether they're using their controller. So what happens here in the update function, it checks if you're not the owner, then just return. You immediately skip out of the update function and you never get to the point where it's going to check, hey, what is your left input mode? By the way, it would never be able to find that information because there's no hands and controllers manager or XR interaction manager for the remote participants because we only see the avatar. So how do we fix that? So the Humanoid network player doesn't know when to turn off finger IK for each of the remote clients. So my thought process is we can see if we can add a network replicated object to our avatar and we pass on the controller hand state. So every XR rig in the process of managing the local avatar, it needs to pass on, I'm now using controllers, I'm now using hands. And then in the remote clients can read that object from the avatar. So let's first go into the Unity UI again. We open up our prefabs and we are going to open up the humanoid avatar. So we have the XR rig with all the fingers, and what we need to do is find some way to post and receive information in there. The official way to do it is that we communicate to the server with RPC, but I have a quick and dirty solution. So we're just going to add an object and we're going to call it avatar has controller. So mixing controllers and hands is not possible in the hands and controllers manager or XR interaction manager. So therefore, we only need a simple function that can turn on and off the IK for all of the fingers at once. So we're adding an object here, avatar has controller. And what do we want to do there? We're going to abuse the scale in the transform. The x coordinate of the scale is going to be 0 if you want to turn off the IK, and it's going to be a 1 if you want to turn on the finger IK. We just do a client network transform, and we don't need to replicate the position, we don't need to replicate the rotation, and we only want to replicate the X scale, because that's where we're going to post this information in. Important to do is that we switch off interpolate here. In this case, we don't need interpolation. So let's add a component, and it's called avatar has controller. So we're creating a script with the same name as the component. We don't need the update. So what we need first is an integer, and let's call it alt hands on controller value. And in the start function, we'll initialize that value with -1. If it is 0, it means that we're going into controllers. And if we are in a 1 state, we are in a hands situation. So this is in a legal state, so that forces a clean startup when we start the application. So we're going to do a public void set, and that has an integer, a value. It does a transform.localScale, and we create a new vector3 value, 0, 0. What we want to do is only pass on the x value. Y and z are not important. We're going to do a get function that is public int without parameter. We need to return the transform localScale.x, but this is a float, so we need to cast that to an integer. So we want to have a function to check whether or not the state has changed. We want to check whether or not the old hands controller value is that's not the same as transform.localScale.x. We also want to have a reset function. So public void reset. We're setting the old hands controller value transform localScale.x. In the reset function, we make sure that the internal value is the same as the actual value so that we can detect state changes later on. Okay, good. So now that is completed. No errors. So now we need to open the Humanoid Network Player script. So first of all, this left has controller, right has controller, we won't need anymore. So let's change that. So we'll uncomment that, and then we'll create a bool avatar has controller. And then we also want to define capital letters avatar has controller, and then we call that avatar HC state. So that's the state that we want to have. So we'll call this WFSBug. So in on-network spawn, what we want to do is immediately after the identification of the network ID, but before the check whether or not you're an owner, we want to identify the link to the avatar hands-on controller state. This state is unique for every individual remote client. So we need to do a transform.find. And we need to find the XRIK rig, and we need to find the object that we just created, which is called avatar has controller. Get component avatar has controller. And from that we can now start calling the methods that we defined in avatar has controller script. So let's go to the update function and see what we need to change. So now we need to make sure that we don't just do a return, but we do something before we do the return. So if not is owner, obviously at the end we want to do a return. A check if avatar HC state dot has changed, because if we have a changed state, we then want to do the following. We want to create X, which is the avatar HC state dot get. So now we're getting the state, doing a debug.log client with ID plus transform get component. Again, don't use GameObjects.find here, just use transform.find, because we need to do this for every unique remote avatar. Network object ID plus, and so if X is 0, that means that they have started using controllers. If it's not 0, then it's started to use hands. So now whenever somebody remotely changes hands or controllers, we get a message in our debug log. And now we do avatar turn on of hands IK, and we want to put a float cast and the X value, because we're now pushing the actual change value. It could either be a 1 or a 0. And then the last thing we don't want to do, a reset. It can again detect new changes. Let's go all the way to the bottom. We can now remove these two functions here. No longer need those. We're going to first add this function at the bottom, and we call that void avatar turn off hands, and it needs to have a float, and let's do a value. What we want to do here, let's go quickly to Unity. We know the fingers have a chain IK constraint, and for that we can turn on or off the weight. So for each of the 10 fingers, we want to turn that off, and the fingers are the only ones that use a chain IK constraint, and they're all children of the XRIK rig. We could fix it this way, say for each in transform.find. So we want to find the object within this current avatar. Please don't use GameObject.find. We want to find the XRIK rig, and within that we want to get all the components in children there. And then what do we want to find there? We want to have the chain IK constraint. And what do we want to do for each of these? We want to say that the weight is going to be the value. Okay, so now we can go back here. Then let's have a look. You see some error messages here already, because if left has controller doesn't exist anymore. So let's comment those out. So in this case we're within the motion controller. If not, avatar has controller. Avatar turn off hands IK, and we're going to push a value into the hands. So say WFSBug turn off finger IK, avatar HC state set. So now we're going to push the value into the object so that all the remote participants can also read that value. And then last but not least, avatar has controller obviously now needs to be made true, because we're going to do this only once. Then we go down and we say very similar for if you're in the hand mode, comment those out. If avatar has controller, but we're now in hands mode, that means that we switch something. Avatar turn off hands IK 1, turn on finger IK. And we also want to let the rest of the world know that we have now started using hands, that's set 1. And then last but not least, let's not forget that we want to say avatar has controller false, because we're now in hand mode. Good. And then finally, what we can do is on the right side, we don't need those anymore. Good. So let's compile this. All right, so I've joined as a host. So let's join as a client. Turn around. So you see I'm using my controllers now. See that the hands are now properly functioning and no longer wrinkled. So let me switch. to hands. You see the message in the debug log that I'm switched to hands, so that now works. Switching back to controllers. Debug log gives the message and my hands are properly working. If I now go into the client and I go to the XRIK rig and I look the avatar has controller, you see the scale is now 0 here. Selecting hands, now I'm in hand state, it's now 1, so IK is enabled. Switch to controller, switches to 0 because it should now disable inverse kinematics. Switching back to hands. Yep, so it looks like our backdoor trick to post information via the local scale, and it has now fixed the issue that we have. And that finally rounds up this episode. And that rolls up part number 6 of our video series building a metaverse. In this episode we have implemented the finger movement of our avatar. So now we have the capability to download any humanoid avatar FBX model and adapt that to our metaverse. Unfortunately, the avatar is still identical for everybody, so that is something that we will address in the next episodes. I'm looking forward to seeing you again soon when we carry on our journey in building a metaverse. Thank you very much and goodbye.